Okay, thanks for inviting me. Good morning, everyone. So I got the task to talk about the potential of language technology and AI, and about the situation where we are and where we should be heading. So let's see how I can fill this title with some content that is related to this topic. And I would especially talk about, I think, the position where we are, and try to speculate a little bit about where we're heading, but maybe not that much. Okay, my name is Jörg Tiedemann, Professor of Language Technology from the Department of Digital Humanities at the University of Helsinki, and I'm especially interested in multilingual natural language processing. You will probably also see that during the talk that I'm especially interested in that. But first of all, slightly some motivation about language technology and why that is interesting and important in the development of artificial intelligence. And if you talk about intelligence, of course, we have to look at human intelligence first. And if you look at human intelligence and intelligent behavior, then this is very much related to the use of language. As we use language in our everyday life and for communication, but especially if we also want to develop our knowledge and explain things that are complicated and try to preserve knowledge, we use language constantly and as one of the most important tools. So if we look at humans, how they become intelligent, it's mostly about using language to reason, to explain, to argue, to understand, to analyze things, to interpret, to listen, to discuss and interact, and so on. So now, of course, if you look at artificial intelligence, as we try to develop something that comes closer to human intelligence, then also language and language technology and speech technology play a big role in developing such intelligence. And if you can see in the global world, then of course big companies and everyone working on AI somehow has realized this and invests quite a lot in language and speech technology. So all these big players that we know about, they invest millions and millions of investments dollars into the development of proper language technology to pick up knowledge and to develop their systems. So probably this is not really the crowd where I have to motivate this too much, but just to point out also that language technology, speech technology is an integral part of AI development. Now, so we also all know that language technology is all around us. So we are kind of influenced by technology that drives all kinds of channels and communication that we do online with our devices in all possible ways, across languages, across different modalities, and using all kinds of applications that we're used to. So actually language technology is quite an important factor in society and how opinions develop and all these things that influence our daily life. So coming to the point of where we are and where we're heading, I also want to go back to actually where we come from. And then if we look at the tradition of language technology, then this used to be an approach that is much more focused on single purpose modules and models that have been developed for a modular approach on language processing and natural language processing, in a way that mostly it comes from a theory-driven perspective, saying that we have some kind of theoretical way or modeling of language that we try to implement either directly in some task-specific model, and then implement a system, an algorithm that can do certain tasks, and then try to evaluate this kind of single specific subtask according to our theoretical knowledge of language, and then use that in some pipeline approaches or whatever we want to do. Another way of doing this is also that, again, if we have some kind of theory of language and language process, annotate some real data and then trying to pipe this into some learning algorithm. And then instead of directly implementing these kind of language specific rules, we can learn them from the data. Mostly this comes with certain limitations. As we can see that we, of course, are very much bound to the theoretical framework that we are working in. And then if we are working on a very specific subtask, this becomes also something that cannot easily be integrated in an end-to-end model that has to perform well from the beginning to the end, but instead we have the problem of error propagation and possibly not a good coverage of the entire system. So in most cases, the kind of drawbacks are that we are bound to these fixed frameworks that we have. We are basically have been working on our favorite framework and the favorite language that we are knowing about. So often this comes down to English and a few other languages. And then this also comes down to very canonical text, which is always treated as a very static and specific way of expressing language. Models also themselves typically have been just for project internal use and have not been widely published. Annotated data possibly, but the projects themselves, the models themselves have not been really widely reused. So now looking at the current situation, or let's look at language first of all. So language as such is much more dynamic and less static as maybe some kind of fixed interpretation of language looks like. But instead, languages develop all the time, they change. They're definitely not independent of each other, meaning that we cannot just treat them one by one and saying that they're independent entities. And we have different explanations for different languages. And also we have to look at that language is our communication tool, which we use in a multimodal and interactive way, so that we should not treat text and spoken language differently. We should see the combination of these modalities and how language is used in its environment and how it is used to solve complex problems between and to communicate between humans. So looking at current trends in language technology, this goes much more into the direction of modeling language as a communication tool between humans, saying that we want to have language as a multi-purpose tool as it is supposed to be. So serving as a communication tool that can solve lots of different problems and not just specific small sub-problems. So the trend now is that we rather go to processing raw data and training some kind of big language model that then covers the essential properties of languages, being the backbone for processing languages in lots of different ways, and then using that kind of big fat language model, as I say in this slide here, to then fine-tune for specific tasks that we then can test on different kinds of benchmarks. So this changes the situation quite drastically. If we now see that we have language models which are kind of essentially modeling the capabilities of languages and their properties, and then we can then use them as the starting point to develop some more task-specific, application-oriented models to apply. And typically we also like to test whether these language models then are capable of performing different kinds of tasks. So instead of just testing one and optimizing for one specific benchmark and application, it is now a common trend that we would like to see how well they work on different kinds of benchmarks. So how flexible is the representation of language that we have? And then there's a lot of interesting ideas also about data augmentation and self-supervision. So in some way, building a system that can more interactively, dynamically learn from language data, produce language itself, and also have a cycle of lifelong learning, as I put it here on that slide. One other thing to point out here is that also those kind of models nowadays, so current trend here is that we go away from just treating one modality at a time, so just plain text, for example, or only speech, or some specific way of expressing language, but instead we want to use a multimodal approach to language processing, having the kind of content and environment and context integrated in a multimodal way in this one big model. And another thing that is important, especially also for our research in Helsinki, is that one would like to go away from treating languages as separate entities, but instead looking at the language continuum, so where we have languages related to each other and influencing each other. And instead of building just models for particular languages, we would like to have a multilingual approach, seeing that language as a communication tool can be trained by using all these different language information together in one model. So this is quite a drastic change to previous approaches, and became very successful with the rise of deep learning and neural network techniques that can make effective use of large data sets. So in a sense, everything in language technology is now focused on meaning representations, trying to get some mapping from language signals into some semantic representations in the middle. So the questions are, how do we get these meaning representations from the signals that we can observe? Why do we need them, and what can we do with them, and how do they look like? So the basic research is really about making this mapping and getting models that can make that mapping. And then we can see here around this circle in the middle, a lot of practical applications that come out of this. So how can this then be fine-tuned for doing machine translation, paraphrasing, or simplification, question answering, or all kinds of applications that we can think of. Okay, so as I'm really interested in machine translation and multilingual models, I just also give the case of machine translation to give you a bit more an illustration how that looks like. So very briefly about the history again. So we started up with more theory-driven approaches to machine translation, looking at languages as a systematic systematic model where we can parse, for example, we can decompose the process into different modules, parsing the input language into some grammatical structures, then transferring it, and then generating from the transferred model in another language. So building the rules by hand or some theoretical framework, and then building that kind of system. So then the move was to statistical machine translation, which essentially is also a rule-based system, but the difference is that now we learn these kind of rules from data instead of writing them by hand, and then doing some kind of decoding according to the system that we have developed and the rules that we have extracted. So now what the current development is in machine translation is that instead we rely on a model that reflects this intermediate mapping of signals that we observe to some semantic representation that is latent or hidden behind the language that we can see. So the neural machine translation system basically tries to resemble understanding and generating and trying to find ways of identifying meaning in some latent space that we don't see and don't know. And there's lots of those kind of models that have been developed, and for many of you who are interested in NLP, you're quite familiar with things like recurrent neural networks and some attention mechanisms and transformers that are behind these popular language models as well, like BERT and others. So this gave a big push also in performance. And we can see that this kind of basic model is now possible to actually also allow further integration of something that I showed in my previous, in one of my previous pictures, that we can now actually treat many languages in just one model. So we can integrate, we can have the same kind of setup for translating between lots of different languages. So we can have a multilingual approach. We can also extend our model to multimodality, saying that we can also, in the same kind of model, treat audio signals and video signals to also influence the meaning representation that we learn. And we can also do lots of interesting multitask approaches to learn these kind of models and systems by integrating different kinds of tasks, not only machine translation, to push the performance of the whole thing. So this is kind of the current state and development of machine translation, and we can see lots of interesting ideas coming out of this, like what is called zero-shot and few-shot learning, meaning that we have very little data for some language pairs, and we can help those smaller tasks by looking at the other tasks around them and other languages that can influence the performance of those translation tasks, for example. So I'll give you a few examples of what we are working on. We have, for example, in the MEMAT project, we work on automatic transcription of videos, and so there's the directly multimodal idea of having audio signals and video signals, but also text if there's subtitles available that can be combined in one system, and we try to make use of those signals to also do translation of information that comes from these videos. So I try to be quick also with the rest of the presentation here. So one thing that is really important is, of course, data, as these neural models are really data hungry. So typically we need a lot of data to train models. In translation, for example, millions of sentence pairs. And this, of course, makes a big problem for people developing these kind of tools and resources for languages where you don't have a lot of resources available. So this is, of course, one purpose for this meeting today here. And we can see that there's a lot of positive developments in increasing the number of public data sets and having the focus on sharing information and data, which basically drives these models a lot. So we need data, but that's something that can be problematic in this approach. So I'll give you a few examples from our side. We work also on the language situation in Finland, and we have developed in the FISCME project something that is, I think, a very good initiative for more systematically collecting data from like public organizations and information that is publicly available for Finnish and Swedish, and try to do all that kind of pre-processing that is necessary to develop improved machine translation systems that can be used in the public domain, but also that can be customized for specific usage scenarios, so that we can distinguish also between public data and research data and some private data. And I think this is very much related to what the ELRC also does on a larger scale in the European level. We also are part of the European Language Grid initiative, and we'll talk more about this in the afternoon. So I take this rather short now, where we try to open up these kind of developments of more resources and tools and pre-trained models for machine translation for many more languages that we can publish through this kind of language grid and different kinds of collections. So here you can see just a picture of the ELG, like public APIs that we want to develop for firing up machine translation systems, but also that in what we call Opus MT, we have published and released over 1,000 models with different channels, like the Hugging Face library that is very popular in your deep learning. And also integration into more professional computer-aided translation tools is also on the way inside of this project. So I will talk more about this in the afternoon. But quickly, because there was also about the future trends, so I also would like just to mention a few things that might be interesting in AI development. And this kind of is related to the statement of the Finnish Center of Artificial Intelligence that goes a lot about data efficiency, trust, ethics, and understandability, with the slogan of doing real AI for real people in the real world. And here I think the focus is really on understandability. So that is something that needs to be developed and should be a future trend to have something that is more understandable as the model. We can understand the model, but also that the models really understand people, and that these kind of AI solutions make themselves understood instead of just giving answers pre-trained on some data for some. So leads to trust. So if we can have systems that we can understand and that make themselves understood, then those systems are more trustworthy. meaning that they can really argue for their claims and predictions instead of just giving answers, and we don't really know whether we can trust them or not. Which I think also leads to some way of self-awareness. So if a system tries to explain itself and tries to explain its own decisions, it needs to be aware of some kind of lack of knowledge internally in the system, which then also leads to some interesting developments of making a system more self-aware of how it should actually learn in the future, what kind of things it needs to pick up, where it is missing information. It can drive for seeking new information outside itself. So this is what we then could call curiosity-driven learning, seeing that the system itself is interested in learning more. So this is what I clearly see as future developments, and in all of those, I really see a clear connection to language technology, as language is the tool for humans to develop knowledge, and it should be in the same in AI systems. So explaining yourself with language is an important goal. Asking for information in a self-driven way is also an interesting goal in future developments. And all these interactive communication that is necessary for developing this should involve language in a multimodal way that should be developed. So I'm kind of running out of time, so I take this example not too much, but just here, this was my basically motivational example. If you have your AI system asking a very complex question, like should Finland join the NATO, and the system just plainly says yes, I guess we cannot really trust and just take that recommendation without further explanations. So a system should be explaining itself and giving the reasons for having that kind of recommendation. So this is my final slide. Basically, what I see in the future is that we need intelligent machines that are able to communicate interactively with language, but they should also be able to explain themselves. So really interacting in a way that is more human-like. They should detect misunderstanding in this kind of communication to also be able to see that where's the communication going wrong. They could then drive this kind of interactive mode to really seek for information in a curiosity-driven learning fashion, and using language for all of that. And with that, I assume that the level of understanding of those systems will go up. So that's it. This is my last slide with some links, and yeah, so I thank you for your attention, and sorry for being a bit